Before we begin, please make sure that you have printed off the PowerPoint so that you can take notes as we go through this slideshow. So in this PowerPoint, we are going to be looking at solving trig equations, and we looked at this in the last section when we were figuring out the inverse sine and the inverse cosine, and arctangent and all those good things. So our question then was something like, if we wanted to find the sine inverse of, call it whatever, equals, let's say the square root of 3 over 2, we're looking for what angle, at what angle does that happen? So we are solving an equation to make this happen. Similarly, when it's worded like figure out the cosine, just like it does here, cosine of what angle equals 1/2. If we're getting x all by itself, we're not allowed to divide by cosine. We have to take the inverse to cancel the cosines. So we're doing with this one up here. I can't just divide by cosine, so I'm doing cosine inverse of cosine x equals cosine inverse of x. That's how this equation came around. I'm sorry, of the 1/2. There we go. And so the cosine inverse of the cosine will get us to the x all by itself. And then we're thinking, well, what angle gives us 1/2 for cosine? And that's where we come up with the pi over 3. But the positive 1/2 happens twice for cosine, and that's how we get the second angle as well. And so coming up with these second angles are going to be problematic. Finding the first one, not too bad. Finding the second one, And so a whole bunch of this lecture is going to be centered around how do we find the others, because it's easy to forget. So let's take a look at where that other one came from. So a couple things go into play to finding that second angle. One of them is considering the period of the cosine function. And so we know that cosine has a period of 2 pi. And we're also going to take a look at the graph of the cosine function. Let's see how well I can do this here. So that's 2 pi. And we know that cosine goes up to 1 and down to -1. So we start up here, we go down here, over here, back up to here. So this is my cosine graph. Okay, so the value of 1/2, that was what we were looking for. So you can see on my quick sketch that there are 2 places between 0 and pi, between 0 and 2 pi that this happens. And our initial answer of x equals pi over 3 catches this guy. We need to come up with the second one. So I'm going to take my 2 pi and subtract off the pi over 3 to be able to come up with that second one. And that's where 2 pi is the same thing as 6 pi over 3. And subtracting off pi over 3 would give me 5 pi over 3. That's where the second one comes from. These graphs, the graph of sine, the graph of cosine, are going to be very helpful to figure out finding the other angle for us as we think through a bunch of these equations. So this slide here shows us not only the portion of the graph that we were focusing on with my quick sketch from 0 to 2 pi, but it shows the entire graph of cosine. And so if we wanted to find every single spot where we hit 1/2, we would be finding what's known as the general solution. And so we could say that the cosine of theta equals 1/2 when theta equals pi over 3 times, plus, that would be what I'm going for. Really, I know this stuff sometimes. Plus pi times n, or k, pick your favorite variable, where n is an integer. So when n is 0, we get our original pi over 3. When you add pi, you get the 5 pi over 3. When you, I think this works. Does it? Does that help us get this next one? Or do I also have to have 5 pi over 3? Because I know from here to here, hold that thought. I might need both of them in there, plus pi n, because this is too close of a distance. Alright, so we'll also have 5 pi over 3 plus pi n, and where n is an integer, fits for that too. And then if n is a negative value, it would give us the ones that are going the other direction, getting us into the negatives. And so what I was writing on the previous slide is exactly what this slide is showing us with the n's, and we do need both of them to make sure we capture the ones that were so close together. Otherwise we'd be missing pieces of the 1/2 answers. So this is another we need to figure out what x equals. And this is considerably more difficult than the one where it just said cosine x equals 1/2. So for a lot of these, we are going to have to use our algebra skills first. And then at the very end, we will be using an inverse sine or an inverse cosine. In this case, probably an inverse tangent to help us out. So let's see. If you want to start this by dividing by tangent, don't, because if we divide by tangent, we will be losing some answers. So instead of dividing by tangent, we are going to get all the tangents on one side. So that would be by subtracting tangent. And so I have 3 tangent cubed x minus tangent x equals 0. And now with a cube, what do you do with a cube? So I'm seeing that I have tangents in both of those, so I'm going to factor one out. And then I'm left with a tangent squared. And I don't know if you can see this yet or not with the algebra involved, so I might make a substitution and say that u equals tangent x, just so the algebra gets a little bit easier. So I have u times 3u squared minus 1. And now if I look inside the parentheses there, u squared minus 1, that would be really nice to factor, but I've got a 3. If it was a 4, we'd be great. So I can't factor my u squared minus 1 because of that darned 3. So I'm just going to set u equal to 0, and then 3u squared equal to 1, divide by 3. And if I take the square root, I'm going to get a square root in the denominator. I also have a positive and a negative because I took the square root, and I need to get rid of a square root in the denominator, so we're pretty good at that. So I now have u equals plus or minus 1 over, no, not 1 over, I got rid of it. That was my whole goal. Square root of 3 over 3. So now that I know what u is, I have u equals 0 back here, and plus or minus the square root of 3 over 3. I can now go back and say that tangent of x equals 0, and the tangent of x equals plus or minus the square root of 3 over 3. And I'm going to go to the next slide to try to figure out at what angles these take place. Okay, so I'm looking for the tangent of x equals 0, so that means I have the tangent inverse of 0 equals x. So basically, tangent is sine over cosine. I need sine to be 0 and cosine to be 1. And when does that happen? So I need sine to be 0 and cosine to be 1. That happens at 0 degrees. So x equals 0 degrees or 0 radians, and that wouldn't happen any place else, I don't think. Tangent goes between pi over 2 and negative pi over 2. I need 0 for cosine. No. Sine has to be 0. That's the only place sine is 0. So that's it. Alright, got an answer. Whoops, got an answer. Then, when does the tangent, so I'm going to do tangent of x equals positive or negative square root of 3 over 3. So tangent inverse, square root of 3 over 3. Let's see. So it's either going to be at a 30 or at a 60 degree angle, and I have okay, so that would it would give us a positive answer at 30 degrees, which would be pi over 6. It would give us a negative answer at negative pi over 6. I didn't write that very well, so if I want the tangent inverse of negative square root of 3 over 3, that's the negative pi over 6. Because in order to get a negative from tangent, we need to be either in the first quadrant or the fourth quadrant from our graph of tangent, and to get negative values, we certainly wouldn't be in the first quadrant, so we have to be in the fourth quadrant, and that would be going down, so negative pi over 6. Okay, so we have another example here, and we want to find the specific answers. We need to get this equation so that it has only one trig function. So this is going to use our trig identities that we worked on in the previous, I don't want to call it unit, but on the previous quiz. And so we need to simplify this cosine, sine, and tangent so that we only have one trig function. And so I see tangent in there that has both sines and cosines. So let's change everything in terms of sine and cosine. So, and tangent is sine over cosine. And right away, I can see we're going to have a fraction. So we need a common denominator. Cosine is missing the common denominator, so I'm going to multiply by cosine over cosine, and that's going to get me cosine squared. I already have sine squared, and then my common denominator was cosine. Sine squared plus cosine squared is a very nice 1. And 1 over cosine, actually I'm going to hang on to that. Okay, so 1 over cosine equals 2 over 1. I don't really want 1 over cosine. I would rather work with this as cosine. So if I flip both sides of my fractions, I would have cosine over 1 equals, not 2, I was flipping both sides, equals 1 over 2. So now I have something that I am pretty comfortable with, and I've done this in one of my previous examples. I'm trying to figure out what angle in cosine gives me an answer of 1/2. And I'm going to do that work on the next slide. So I'm looking to solve, it was cosine x equals 1/2, so I'm looking to find the cosine inverse of 1/2 equals x. So at what angle does this take place? X would be pi over 3. And then to make sure I get all of the angles where this takes place, just a quick refresher, I know that cosine goes up to 1 and down to -1 between 0 and 2 pi, and this happens in 2 spots. Here's my 1/2. So I've got this one, and I need to find that one. So since the period is 2 pi, I'm going to take 2 pi and subtract off pi over 3. And if I take 2 pi and subtract off pi over 3, I wind up with 5 pi over 3. So those are my two answers. X equals pi over 3 and 5 pi over 3. Okay, now in this one, my original problem is right here. And I need to solve for y in that. And the algebra involved is getting a little complicated. So I want to make the algebra simpler. And I'm going to do another substitution in here by taking out the sign and replacing it with another letter so that my algebra gets a little less involved. And I'm actually going to put it on another, I know it's all written out here for you, but I'm going to walk you through this so that we can work on the algebra once we know that u equals sine y. So hang on to that, and we'll take a look on another slide. Okay, so we're working on, with our substitute, because we had 12 sine squared y minus 13 sine y plus 3 equals 0. And we said that we would say u equaled sine y. So that would be 12u squared minus 13u plus 3 equals 0. So now we have a quadratic. And it'd be really nice if we could factor this quadratic. Or you could use the quadratic formula. So pick your favorite poison. And I'm going to show you my way of factoring this, which is different from the way that was up there. I'm going to take the 12 and the 3, actually the first and the third, and I would get 36u squared, and I'm looking for factors of 36u squared that add to negative 13. So I see that that would be negative 9u and negative 4u multiplied to positive 36, and then they add to negative 13. And you may have never seen this before, but this is called the box method. And in the box, I'm going to put my 12u squared in the top left, my first term. I'm going to put the 3 in the bottom right, and then the two factors that I found go in the other two boxes in either order. And now I'm looking for common factors vertically and horizontally. So the common factor from this first column, I see a 3u. Common factor here, it has a 1. The fact that there is a negative right here tells me I'm taking out negative 1. On my top row, there is a 4u, but because the 12 is positive, on that edge, I'm not making, it's not a negative. It's a positive 4. Then I'm looking at my factors from the bottom row. I see a factor of a 3, and because the 9 is negative, I have a negative 3. What I have pulled out from here and here, those are the factors, 3u minus 1 and 4u minus 3, that now equals 0. So I have to set each of those equal to 0, so u equals 1/3, u equals 3/4. Unfortunately, when I go back to set this into, remember sine y equals 1/3, and sine y equals 3/4, those are not values that show up on the unit circle. So when I do the sine inverse of 1/3 or the sine inverse of 3/4, I have to use my calculator to get those answers. And I would really rather have them in degrees personally, but I think the question asked for it from 0 to 2 pi. So in radians, on your calculator, let's see what we can come up with. So mode, radian, inverse sine of 1 divided by 3. Oh, we get a gorgeous answer. We get 0.3398 8. And then inverse sine of 3 divided by 4 is 0.848, and I'm going to round up 1. Okay, so now how do we know if there are any other places where this happens? We're going to go take a look. So these are definitely values for y. We're going to go take a look at the graph of sine to see if we need to find any other values where the sine is at positive 1/3 or at positive 3/4. So let's go look at a picture. So here's the graph of sine, and you can see where it happens, that we get about 1/3 and 3/4, and sure enough, there are other spots where this happens. Right over here and right over here. And the question is, how do we find that? It's not as easy as just using the period and subtracting from 2 pi, because that would give us answers down here, and our graph is clearly not intersecting at those locations. So with sine, we're working off of pi. So drawing the picture, draw the graph. Whether it is the graph of sine or cosine or tangent, we need to see where the value, like whether it's 1/3, 1/2, 3/4, whatever it's supposed to equal, we need to see where it intersects. So you know if you're subtracting from pi, if you're subtracting from 2 pi, otherwise it's a lot of stuff you have to memorize. So we need to take, I'm going to start with the 1/3 value. I'm going to take pi minus 0.3398 and see what that gives us on the calculator. And that's about 2.802. And then pi minus the 8481. And that's 2.293. So our 4 answers for this, y equals, this is in numerical order, and here's my set, 0.3398. 0.8481, 2.293, and 2.802. There we go.